All right, thank you for joining us today. And in this video, we have 8 set questions that we are going through together. Right, so let's start. First, we want to find derivative of the following functions here, right? So I'm going to take them one by one. We go through, then we move to question 2 up to question 8. Okay, so stay here with me. All right, so first one, we have y is equal to 4x to the power 7 minus 6x to the power 3 minus 7, right? And you want to take the derivative. So this is very simple. We are going to use a power rule because it's a polynomial function. So a y prime will be equal to, so let's use the power rule. So I'm going to have 4 is multiplying the function, so I just factor 4 out. Then when I differentiate x to the power 7 using the power rule, I'm going to drop the 7. Then I'm going to have 7 minus 1. Then minus, I factor the 6 out. I differentiate x to the power 3. I'm going to have 3x 3 minus 1. Then when I differentiate a constant, we know that we are going to get 0. So simplifying this, we are going to get now 7 times 4 is going to give us 28. Then this is going to give us 6, right? So you can do it straight 2 as well. And then 6 times 3 is going to give us 18 minus 18x to the power 2. So this is what you are going to get after differentiating the function. That is very simple, right? So very, very simple from there. B, let's take B. Now B, we have this function here, right? We want to differentiate, but we can see that the first function here is a product rule because we have x to the power 5 and then e to the power 3x. Don't mind this function here because we know that when you differentiate this, we are going to get 0, right? So what I'm going to do is I'm going to let this one to be a and this one to be b. So a is equal to this and then b2 is equal to this. So based on that, we need to use the product rule, right? So we are saying that a is equal to x to the power 5, b is equal to e to the power 3x. So what is a prime? Using the power rule, we are going to get 5x to the power 4, right? We know how to use the power rule. Then when I differentiate this, what am I going to get? I maintain the function. Then I differentiate what is on the top, 3x. So I maintain the function. Then I differentiate what is on the top here. So I'm going to have e to the power 3x times 3. And this is the same as 3e to the power x. Sorry, 3x. Good. So this is what you are going to get. So now from the product rule, we need to multiply a to b prime and b to a prime. So we are going to have y prime is going to be, so product rule, I'll multiply this and that. I'm going to have x to the power 5 times 3e to the power 3x plus, then I'll multiply this and that. I'm going to have 5x to the power 4 e to the power 3x, right? Then if I want to do some small simplification, I'm going to have 3x to the power 5 this plus 5 4e to the power 3, right? Now don't forget we have this function here, but when I differentiate after using the product rule for this one, when I differentiate negative 13, I'm going to have minus 0 because I will get 0. So this is what I'm going to get at the end of the day using the product rule. Here, if you just want to do some manipulation here, you can say, oh, factor 4 x to the power 4 e to the power 3 out. And here is going to be left with 3x plus 5. So this is what you're going to get if you want to simplify. But you can just leave your final results in this form and you are okay. Right. So that is the idea. So you see what we did here? We just picked the product rule here. We did it and then we put it here. Then we differentiated the minus 13 and we are getting 0 here. And this is the final results here. All right, let's look at C. C here, we need to use quotient rule, right? So I'm going to say that this is equal to u divided by v. Then by the quotient rule, what are we going to get at the end of the day? So it means that y prime is equal to v u prime minus u vn prime divided by vn squared. So that is the quotient rule. So now what is u? U is equal to x to the power 3. What is vn? Vn is x squared plus 1. So from what we just did here, so u is the one on the top, and then vn is the one on the down. So what is u prime? Because in the formula here we have u prime, we have vn prime. So we need to look for u prime. U prime is equal to 3x squared using the power rule, and then vn prime will be equal to, when I differentiate x squared, I get 2x. When I differentiate 1, I get 0. So that is that. Then now let's do substitution. What is vn? Vn is here. So x squared plus 1. What is u prime? That is 3x squared minus, what is u? X to the power 3. And what is vn prime? 2x, all divided by vn squared. So vn is x squared plus 1, which is squared like that. So I can leave my answer in this form, but I can also do some small simplification here. I can multiply this one to this and this one to also to this. So I'm going to have 3x to the power 4 plus 3x squared after multiplying this to what is here. Then I'll multiply this to also this. I'm going to have minus 2x to the power 4 divided by x squared plus 1 squared. So when I do that now, this term and this term are the same. So 3 minus 2 is going to give us x to the power 4 plus 3x squared divided by x squared plus 1. Yeah. So this is what you are going to get for the C using the quotient rule. All right. Now let's look at the D. Let's look at the D. Let's look at the D. So with the D, we can see that we need to use the change rule, right? So there is power rule in there. We have change rule too as well. But we learned the short way for, applying change rule, right? So what are we going to do? Y prime D. Y prime is going to be equal to, so first we are going to apply the power rule on this function here, 12. So this 12 will drop down. So I drop the 12. Then I maintain the whole function. So look at how I'm doing it. I drop what is here. Then I maintain the whole function, which is 3x to the power 10 plus 5x to the power 6 to the power 12. So what happened? 12 drops down. I maintain the whole function, but the power rule says that I should subtract 1, right? Then now I'll multiply this one by, because we are using the change rule, I need to multiply this one by the derivative of what is inside the what? The parenthesis. So we are going to have d over dx. What is inside the parenthesis is 3x to the power 10 plus 5x to the power 6. Good. So this is going to give us 12, 3x to the power 10 plus 5x to the power 6. Then 12 minus 1 is 11 times. Now I use the power rule to differentiate this. So when I differentiate x to the power 10, I'm going to get 10x to the power 9. Then I'll multiply the 10 by 3. So I'm going to have 30x to the power 9 plus 6 will drop down and multiply the 5. So I'm going to have 30 again, then x to the power 5. So this is what I'm going to do, or this is what I'm going to get. I'm not going to simplify anything again because we cannot simplify anything here. We cannot multiply this one to itself 11 times. So we are going to leave our final results here. So don't forget the change rule. Instead of letting u to be equal to this, doing the whole long process, what you can do is anytime you see that it is a change rule, drop the 12, maintain the whole function, and then subtract 1. When you are done, take the derivative of what is inside the bracket. Don't forget, take the derivative of what is inside the parenthesis. Right, so that is what is going to give us the D. Right, now let's look at E. Let's look at E. With E, what I'm going to do is I will simplify the function. So I said anytime I have a radical, I need to simplify it first. So I have y is equal to 9 cubic root of x plus 3 over x. So I can simplify this and have my y to be 9 x to the power 1 over 3, right? Plus, now we learn how to also simplify this. This can be written as 3x to the power minus 1 because the power here is 1, right? So if I want to take it from the denominator and move it up, then the sign here, since this is 1, it changes to minus x, minus 1. Good. So now that I've done this simplification, then I can apply the what? The power rule. So what the power rule says? Now y prime will be equal to, now I'll drop the 3 down. So I'll maintain my 9, drop 1 over 3, then subtract 1 from this. So I'm going to have 1 over 3 minus 1. That's the power rule. Plus, I'll maintain my 3. I want to differentiate x to the power minus 1. I will drop the minus 1, then minus 1, then I'll subtract 1. So I'm going to have, now this times this is going to give us 3. Then 1 over 3 minus this. So we know the trick, right? If I want to find a fraction for this one here is the same as divided by 1. So we know the trick. This times this. So first, second, third. So which one is the first? This. So 1 times 1 is 1. This will multiply this, minus 3 times 1 is 3, divided by the third is, we go this way. So first is this, minus second is this, then divided by the third, which is this times that. So you're going to have 3. So the top is going to give us negative 2 over 3. So that's what you're going to get here. Negative 2 over 3 plus, sorry, 3 times minus 1 will give us minus 3. Then minus 1 minus 1 is minus 2, right? So this is what you are going to get at the end of the day. If you want to simplify, yes, you can go ahead and simplify, and you are going to get something like this. And you are going to get something like, this is the same as 3 divided by x to the power 2 on 3 minus 3 divided by x squared, right? So we can leave it in this form. So this is the E. This is what we are going to get for the E. Let's look at F, right? So F is a length function, and I have videos on how to differentiate each individual function. So you can also check it out. Now let's look at F. Now y is equal to ln of 5x. So we said for us to differentiate a ln function, 1 divided by what is inside the parenthesis, which is 5x, all times the derivative of what is inside the parenthesis. Good. So it's very simple from there. So 1 over 5x times, when I differentiate 5x, what am I going to get? There's 5. And then, fortunate for us, 5 will cancel 5. So our final result is going to be 1 over x for the F. Right. Let's look at Jane. So Jane, as I said, still this is going to be, we need to change the radical. So we are going to have x to the power 3 minus x all to the power 1 over 2. So this one we are going to use the idea of change rule to also differentiate that. Right. So let me write it here. So now y is equal to x to the power 3 minus x to the power 1 over 2. So let's use the change rule. So y prime will be equal to, so the trick here is the short way. First apply the power rule on the power here. So 1 over 2 will drop down, which is the power rule. Then when I drop the 1 over 2, now I will maintain the whole function here. So I'm going to have x to the power 3 minus x, and then I'm going to have 1 over 2. So I drop this, I maintain the whole function. But we are applying the power rule, so we need to subtract 1. But don't forget, this is a change rule too as well. So I'll multiply it by the derivative of what is inside the parenthesis, which is x to the power 3 minus x. So that's what I'm going to get at the end of the day. Good. So this is what I'm going to get. Now let's do the simplification. I'll have 1 over 2 x to the power 3 minus x. 1 over 2 minus 1 is minus 1 over 2. Then when I differentiate x to the power 3, I'm going to have 3x squared. And when I differentiate x, I'm going to get 1. So this is what I'm going to get at the end of the day. So I'll just leave the final answer here, and then I'm done. Now let's do h. So this was the gene. Now we want to differentiate this. So y is equal to x to the power 3 plus 7. So as we said, we just differentiated a length function. Y prime is equal to 1 divided by what is inside the parenthesis, x to the power 3 plus 7, times the derivative of what is inside the what? The parenthesis, plus 7. So what are we going to get? 1 over x to the power 3 plus 7. Then when I differentiate what is inside the bracket there, when I differentiate x to the power 3, I'll get 3x squared. When I differentiate 7, I'm going to get 0. So my final result should be 3x squared divided by x cubed plus 7. So this is what I'm going to get for the H2. Let's do the last one on derivative here. What is the I? The I here. So with the idea of derivative, as I said, first know how to differentiate all individual functions, right? So at the end of this video, I'll place the next video that is going to pop up on the screen will be how to differentiate individual functions. So you can go and check it out, how to differentiate individual function. When you are done or knowing how to differentiate individual function, then all you need to know is you need to know the rules of differentiation. So you will see that when I see this, oh, I need to use the quotient rule. When I see this, I need to use the product rule. When I see this, I need to use the change rule, right? So that one too, I'll just place the link there for you to also watch it out. So let's look at I. So I, you are going to use the quotient rule. So my U over VIN. If you don't like the U over VIN, you can also say something like F over gen. It's the same thing. Anyone that you want to use is the same thing. So it means that y prime based on the quotient rule VIN u prime minus u VIN prime divided by VIN squared, right? So what is my u based on the this, and then this is VIN. So I'm going to have x squared minus 5, and VIN is equal to e to the power x, right? So what is u prime? Is just 2x, right? When I differentiate this, I get 2x. When I differentiate this, I get 0. Then what is VIN prime? So we know how to differentiate e to the power x. So by this time, you should be able to know that when I differentiate e to the power x, I'll get e to the power x. So no much time wasted, but I'll just do it. This, you maintain the function times the derivative of what is on the top, which is x. So this will be e to the power x times 1, and this is going to give us e to the power x. So some of the function, you just need to know them that, oh, when I differentiate this is what I'm going to get. But don't forget, learn the process, right? That's why I showed you the process, the video that I want to show you, the process, so that if it is not e to the power x, which you know that is going to give you ex, and it's different function aside ex, you'll be able to also differentiate. Now let's plug them in inside the function. VIN is this, so I just plug it there. Then what is u prime? U prime is this, so 2x minus u is this, so x squared minus 5. You see, when I wrote the x squared minus 5, what I need to do is I'm going to put it into what? Parentheses. You cannot just leave it like that. If you do it that way, you might make a mistake. So what is VIN prime? VIN prime is just ex divided by VIN all squared, right? So what are we going to get at the end of the day? Let me shift this one here small. This is the same as ex, and then move this one up small. Good. So we are going to have, when I multiply, I'll have 2x e to the power x minus. Okay, fine. So this will be very simple for me to do this. Since I have ex here, I have ex here, I can factor it out, right? So I'm going to have ex out, and what will be left here is 2x minus what is going to be left here when I factor this one will be this. So I'm going to have x squared minus 5 divided by, this is the same as this one here. Because I want to do cancellation, I can write this one as ex times ex, so that one of the ex will cancel one of the ex, right? So this is going to give us 2x minus x squared plus 5 divided by ex. So this will be there. final result for differentiating this particular function. Right. So we are done with the first question. Let's go to the second question. So the second question, we have this equation here, and we want to find the slope of the tangent, right? So the slope of the tangent is dy over dx. So it means that we need to differentiate this function here, right? Then we use the slope to find the equation of the tangent line, right? So let's pick it up. So x squared plus xy minus 2y to the power 3 is equal to minus 13. So as I said, anytime you have a function where you have x and y and you cannot make y the subject, like for example, this one, you see that we have only y here and we have the x on the right side, right? So this is like explicit. X is standing alone, y is also standing alone. But this one, we have y is not standing alone. Y and x are like kind of attached together, right? And then you can also see here that the y values that we have here, they are all to the power 1, right? But when you get implicit differentiation, we see that if it is not to the power 1, then it is also, if it is to the power 1, it will be attached to x in a such a way that you cannot make y the subject. If let's assume that we don't even have this, so we are going to use the implicit because this is not to the power 1, it's to the power what? 3, right? So that is the idea. So here we are going to apply the implicit differentiation, right? But don't forget, we are differentiating this with respect to x because we know that the slope is equal to dy over what? Dx, right? So implicit differentiation, I'll just teach you here. When I'm differentiating 2x, I'm going to have 2x, but with the implicit differentiation, when you finish, you need to multiply it by the function that you differentiated here divided by what you are differentiating with respect to. So this one is like, this one I'm going to multiply this one by dx because I'm differentiating x. Dx divided by what am I differentiating with respect to? Another dx. So you see that this one will cancel this and it will be 1. So you won't see it. Good. Plus, now since this is an implicit differentiation, this is a product rule. So don't forget, this is a product rule. So what does the product rule say? If I maintain x, then I need to differentiate y. When I differentiate y, what am I going to get? Dy over dx. Plus, now I will maintain y, right? I maintain x, I differentiate y. Then now I maintain y and differentiate x. So when I differentiate x, what am I going to get? 1, right? But the idea is that it's like dx over dx, right? Which is going to give us 1. So I can clean it up there. And even this one too, I can also clean it up there. This one too, I can clean it up because since we are differentiating it with respect to x, then when I differentiate x, there is no need for me to multiply it by the x over the x because it's going to give us 1, right? So since we are differentiating with respect to x, this will give us 2x. Product rule, I maintain x, I differentiate y, plus I maintain y and differentiate x, and I'm going to get 1 minus 2. When I differentiate y to the power 3, what am I going to get? So it's like here we are going to use the power rule. So 3 drops down, then I subtract 1. So this is going to be squared. But don't forget, you need to multiply it by dy over dx because this is an implicit what? Differentiation. And we are differentiating y, not x. And this is going to be equal to 0 because when I differentiate negative 13, I'll get 0. We don't need to do any hard work here. What we just need to do is, since the point is given to us, then we don't need to even make dy over dx the subject. We can just plug them in before making dy dx the subject. So as I said, anytime you have this point here, this point here is x1, y1, whenever you are putting it inside the what? Equation of the tangent. But this point here changes to x and y when you are dealing with the slope. So since we are dealing with the slope, this is x and this is what? Y. So let's plug them in. This is going to be 2 times 1 plus 1 dy over dx plus this is y. Y is 2 times 1 minus 2 open bracket 3. Y is 2 squared dy over dx, which is equal to 0. So what are we going to get? 2 plus dy over dx plus 2 minus, so this is going to be 2 2 squared is going to be 4. 4 times 3 will be 12 dy over dx, which is equal to 0. This 2 and this 2 is going to give us 4. So 4 plus dy over dx. And then when I multiply these two to this, I'm going to have minus 24 dy over what? The x, which is equal to 0. So if I want to bring this one up here, then now we have dy here, we have dy here. The coefficient here is 1. So 1 minus 24 is going to give us plus 4 minus 23 dy over dx, which is equal to 0. Right. Then we want to make dy over dx the subject. So what I can do is I can move this one to this side, or subtract 4 here, subtract 4 here. So I'm going to have minus 23 dy over dx, which is equal to minus 4. Then I will divide this one by minus 23, divide this one by minus 23. So dy over dx will be equal to minus 4 divided by minus 23. Minus will cancel minus, and we are going to have the slope to be 4 divided by 23. So this will be the slope that we are going to use. So now that we have the slope, what next? The next question is to find the equation of the tangent line. So this is 4 divided by 23. So we've done the hard work. The rest, the equation of the tangent is just knowing the equation. So that's one thing about when you are dealing with implicit differentiation. When you are done with this whole hard work here, right? You are done. The rest is just knowing the formula and just doing substitution. That's all. So let's see what we are going to do here. So now that we've done the hard work, we are done finding the slope. That's the hard work. Now what next? Now we know the equation of the tangent is y minus y1, which is equal to the slope x minus x1. So the m, which is the slope, is what we've just done here. So this is equal to the m. So this is the hard work that we've done. So the rest is to do substitution. So as I said, this is x, this is y when you are working with the slope. Now this changes to x1 and y1 when you are dealing with the equation of the tangent. Don't say that this is x, this is y, because if we put this one as y and put this one as x, you get it wrong, because our equation should be in terms of x and y. So now this is x1, this is y1. So you see, I said we've done the hard work. The rest is substitution. So let's go. Y minus 2 is equal to, we've done the slope, which is 4 over 23, then x minus 1. So this is the slope. We can just leave it here, or we can say, okay, let's simplify. Y is equal to 4 divided by 23, x minus 1. So when I add plus 2 here, I'm going to have plus 2. I don't want to simplify. I can just leave it this way, and I'm done. So this is the equation of the tangent. So the hard work here, when you are dealing with implicit differentiation and they are asking you to find the equation of the tangent line, is by finding the slope. When you're able to find the slope, the rest is just substitution. Right. Now let's look at question 3. Question 3, we assume that we have the price demand equation to be this. That is Q, right? Then we want to find the elasticity function, E of P, right? So the first thing that we need to know here is we need to remember is the formula for finding elasticity function, right? So we know that E of P is equal to minus P F prime of P divided by F of P. But don't forget, remember we said K is the same as F of what? F of P. So if K is the same as F of P, then we can change the formula by saying that this is the same as minus P K prime divided by K. So don't get confused when you have this and the function given to you here is K, right? So that is the idea, right? So, or if you don't want to change the formula to this one too, you can say that, okay, this is also the same as F of P, and then use that idea. So what's the hard work here? The only hard work here is to find K prime. That's all. That's the only hard work here. The rest is substitution. So let's go through the hard work. What is K prime? So they've given us K to be equal to 600. They've given us this one to be equal to 600 minus p to the power 4. So what is Q prime? Q prime, when I differentiate 600, it gets 0 minus. When I differentiate p to the power 4, remember the function is in terms of p. So we are differentiating with respect to p. So power rule 4p to the power 3. And this is going to give us minus 4p to the power 3. So this is the hard work. This is just the hard work that we just need to do. The rest is just substitution. So what is E of p? E of p will be equal to minus p times, what did we get for Q prime? Q prime was minus 4p to the power 3, which is here. So we are just doing substitution. Divided by, what is Q? Q is this, what is given to us. So this is going to give us 600 minus p to the power 4. When I multiply, I'm going to have minus minus to be positive. So I'm going to have 4p to the power 4 because I have p here and p here. And this is going to give us 600 minus p4. Please, I've been seeing these mistakes. Don't cancel this and this. You cannot do that. If you want to cancel something like this, the thing that you want to cancel, you see that this one is multiplying this. If this 600 is also multiplying this, that's when you can cancel. So you cannot cancel this. And I saw that some of you can cancel this. When you are done, then you cancel this one too, which is not possible. Because of this minus here, we cannot cancel. We can cancel something like this. P to the power 4 divided by, let's say, 12 times 600 minus 4. Good. We can see that we can cancel 4 and 12. Why? Because this 12 here is multiplying this and multiplying this. This is something that we can cancel. So when you get here, just leave your results just like that. That's all. Don't try to cancel anything. So this is the A that we need to do. Now, B2 is not hard work, right? So we want to find the elasticity when price is equal to P. Is equal to $10. So that is the thing that we want to do. So now when P is equal to 100, right? Oh no, 10, 10. So we are going to have E of 10 to be equal to. So we just do substitution here because E of P, this is our E of P. Very simple from there. So this is going to be 4 times 10 to the power 4 divided by 600 minus 10 to the power 4, right? So 10 to the power 4 is going to give us, like, I think 10,000. I think so. 10 times 10 is going to give us 100. 10 times 10, 100. 100 times 100 is going to give us 10,000. Yeah. So 10,000 times 4 is going to give us 4,000. Okay, let me do it. So 4 times 10,000 divided by 600 minus 10,000, right? So this is going to be 40,000 divided by minus, when I do the subtraction, I'm going to have 9,400, right? So I can cancel this 0 and this 0, this 0 and this 0. So I'm going to have something like, I'm not using calculator, so I'll just leave it 40 divided by minus 94. 2 can divide 40 by 20 and divide 94 by, I think, 47. So this will be the final result, minus 20 over 47. Yes. So what can we say about this, which the question has not asked us for? So we can see that since the denominator is bigger than the top and it's even minus, this is less than 1, right? So this is price inelastic, right? This is inelastic. Now, what's the last one? That is the C. The C is saying that for which price P does an increase in price also increase the revenue. So increase in price also increase the revenue is at, when we are talking about what? Inelastic. So it means that what we need to do is we are looking for the price when it is less than 1, right? So this is inelastic. That is when an increase in price also increase the revenue. So now what do we need to do? We are looking for the price because for which price. So for us to solve this, we need to look for E of P. We've done the hard work already. E of P was equal to this. So I'm going to bring this one here. So I'm going to have 4P squared, no, to the power 4, 600 minus P to the power 4, then less than 1, right? So see what I did? I knew that an increase in price, which also increases the revenue, is this. Now I know this, we've done this one already, which is equal to this. So I'm going to replace it by this. Then now find for P. So I'm now going to solve for P. So what am I going to do? This is divided by 1, so I can multiply this one by this and multiply this one by this. Or I can also say I'll multiply this one by minus, right, 600 minus 4p, then multiply the right hand side too by 600 minus 4p. Why did I do that? I want to cancel the denominator, so I pick the denominator to multiply this, right? So now when I do that, I can see that now this will cancel this. So what will be left on the top? 4p to the power 4 less than the one I multiply 1 by this, I get the same thing, 600 minus 4p. So what am I going to do? I'm going to add p to the power 4 here, p to the power 4 here. Here, please, when you are here, be careful, because mostly some of you when you are doing this, you get it wrong, right? So when I add minus and plus, this one will be 0, right? But this is 4, this is 1, right? So 4 plus 1 is going to give us 5. So you are going to have 5p to the power 4 less than 600, right? Because this will cancel this, because minus of this plus this will be 0. Then now, what am I going to do? I'm going to divide this one by 5, divide this one by 5. So this implies that p to the power 4, because this one will cancel this, is going to be less than, now 5 goes to 60, how many? 12, right? So it means that we are going to have 20, right? I think so. No, 12, so it's going to be 120, right? Right. So 120 times will give us 600, I think so. And then now let's pick the fourth root on both sides, right? So what I'm going to do is I'm going to pick the fourth root, because this is 4. That's a less than or equal to less than the fourth root of 120. So what will be P? P will be less than. So let's see here. If you cannot do it, you can leave your answer in this form. But I want to think of something like if we can write 120 to the power 4, something to the power 4, that is going to give us 120. So 2, no. 3, no. 4 to the power 4. What is 4 to the power 4? 4 times 4. Oh, let me say 5 to the power 4. 5 times 5 times 5 times 5. So this is 25. And then this also going to give us 25. So let's multiply. No, I think this one will be more than 25. So we just leave it this form. I thought we can get 120 to the something to the power 4 so that we can cancel it out. I'm sure you should be able to do something like that, but I'm not all that sure. I'm not that sure that if we can get something that when you to the power 4 we are going to get it. But if you have calculator, you can check it out and see if you have that. So this will be the price if we get it. This will be the price. So let me write it here. This will be fourth root of 120. This will be the price that an increase in price will also increase the revenue, right? So this is question 3. Let's go to question 4. Suppose we have another product that has price demand equation to be this, right? And then X is the number of item produced. So here you need to put information down. So X here is the number of item produced and P is the price, right? So P is the price, right? So the first question is find the revenue function. So What is a revenue function? We know that revenue is equal to quantity times what? Price. But let's see something here. We can see that our revenue is in terms of X. So we need to make sure that this is also in terms of what? X. So it means that we need to change the P. But good. Price was given, right? Which is P. So we don't need to do any hard work by doing substitution. So this is going to give us X times, we know that P is equal to what is here. So 30 minus 0.1x or zero point 0.1x, and then when I multiply, I'm going to have 30x minus 0.1x squared. So this is the revenue function, right? Now, if demand is increasing, so we ask ourselves, what is demand? What is demand, right? So if demand is increasing at the rate 10 units per week, when demand is 50, what is the rate of change for revenue? So what is the demand? Now the demand here, the demand word that we mentioned here is we are looking at the X, the what we are producing. Like, so when you say the demand, so if people are demanding more, then it means that we need to also produce more, right? So it means that the demand that they are mentioning there is the X, right? Is the X there. That's what we are looking for. So it means that now X changing, because we are talking about a change, right? So let me write the B here. So if a price is increasing, so let's now per week. So this divided by um this divided by the X over the T should be equal to 10, and then X is equal to 50. So the demand here is 50, and then we have the change too. So what we need to do is we need to now find the change in revenue, right? We are going to find the change in revenue. So what will be change in revenue? This is revenue. So we saw that revenue is equal to 30x minus 0.1x squared, right? So this is what you are going to differentiate. So the change in revenue means that we need to differentiate R with respect to T, right? So now when I differentiate this, what am I going to get? I'm going to have 30 dx over the T minus, when I differentiate this, what am I going to get? I'm going to have 0.1 out. When I differentiate x squared, I'm going to have 2x, but we are using implicit, so this one should multiply by the x over the T, right? The x over the T. So that's what you are going to get at the end of the day. So now the x over the T is given, that is the rate, change in rate, and then x is also given. So we don't need to do any hard work, we just do substitution. So 30 times the x over the T is 10 minus 0.1, 2 times x is given, which is 50, then times the x over the T, which is also 10. So all we just need to do is just simplify. So this is going to be 300 minus 0.1. 2 times 50 is 100. 100 times 10 is going to give us 1,000. Yeah. Is it 1,000? Yes, of course. So that's how it's supposed to get. So we get 1,000. Yeah, 1,000. So now this will be 300 minus 0.1 times this is going to give us 100, and this is going to give us 200, right? So this will be the change in revenue. So that was going to be the B. What is the change in revenue? So always make sure you underline the right words to get the terms done. Let's look at question 5. So question 5, given the price demand, which is x is equal to this, and then the cost function, which is also equal to this. First question is find the revenue function. Okay, so that's what we were just something similar that we were just trying to do there. So let's find revenue is equal to X times P, right? Price times P. Now this is in terms of X, as I said, and we need to look for P, right? But here, this one was fortunate. We had P. But this one we are not fortunate because we don't have P. But since we have one equation here which is involved P, then we can take this equation and make P the subject, then we come and put it here. Right. So let's do that. X is equal to 300 minus 4P, right? So let's make P the subject so that we can do what we want to do. So what I'm going to do is very simple. I'm going to add or subtract minus 300 here, minus 300 here. So I'm going to have X minus 300, which is equal to minus 4P, because I want to make P the subject. Then the next thing that I'm going to do is I'm going to divide through by minus 4, divide through by minus 4. So I'm going to have P to be equal to X minus 300. Let me bring it up there, here, divided by minus 4. So this is what I'm going to get at the end of the day. Now, if I want to pull the minus up, right? If I want to put the minus up, this is going to be minus X minus 300 divided by 4. Then when I multiply the minus through, I'm going to have something like this. 300 minus X divided by 4. So that will be my P, which is my price. So now, since now I was able to make P the subject, then X times 300 minus X divided by 4. And then this is like divided by 1. So the top will multiply the top and the down will multiply the down. So we are going to have 300x minus x squared divided by 4. Good. So that's what you are going to get for the revenue function. B. Find the profit function. So here we want to find the profit function. So we know that profit is equal to revenue minus cost. So if profit is equal to revenue minus cost, what is revenue? This was the revenue function, right? So we have 300x minus x squared divided by 4 minus, do we have cost? Good, we have cost. So this is the cost here. We are fortunate. So I'll put it in parentheses, 5x plus 40, so 40. Right. Now, what can we do? We need to just do some simplification here, and then we see what we can do here. Right. So what we can do here is very simple, but let me show you how we can do that. So this is like over 1. So we are bringing our idea of left, right, that kind of thing, so that we can, this is divided by 1. So let's do the left, right something. So first, second, third. First, second, third, right? So what's the first one? This multiplies this. So 1 times this one is going to give us 300 x minus x squared times 1 minus second, we go this way, so this will multiply this. So we are going to have 5x plus 40, then divided by, what is the third? Divided by, we are going here to this side, so 4 times 1. Good. So that's what we are going to get at the end of the day. Let me just move this to the top so that we can work from there. Okay. Let me see. Okay, so let me try and see if I can put it here. So this is going to give us something like this. And when I multiply the 1, I'm going to have 300x minus x squared minus, when I multiply the 4, I'm going to have 20x and then minus 160 divided by 4. So let's do the simplification. What are we going to get? So I have this one here, this one here. When I do the subtraction, I'm going to have something like 280x minus x squared minus 160 all divided by 4. So this is the revenue function. This is what you are going to get for the revenue. Right. Did I say revenue? The profit function, sorry. This was supposed to be a profit function. All right, so now that we are done with the profit function, C is saying that find the marginal revenue function. So for the marginal revenue function is just the derivative of the revenue function. So let me put it up here. So C, we want to find the marginal revenue. So marginal revenue is just R prime. So we have R of X to be equal to 300 X minus X squared divided by 4. Right. So don't forget this function here, don't think of using the quotient rule. When you use the quotient rule, you get the same thing. But since the denominator is constant, we can pull it out. So 1 over 4 out, and it will be left with 300 X minus X squared. Right. So using the product rule, R prime will be 1 over 4 out. Then I differentiate just what is inside the parenthesis because this is a constant multiplying what is here. So I'm going to have, when I differentiate 300, what am I going to get? Oops. I'm going to have 300. Then when I differentiate x squared, what am I going to get? 2x. So this will be the marginal revenue. Very simple. Very simple. Now let's look at D. Use the marginal revenue function to estimate the change in revenue for producing the 101 first item. So what you are going to do is, as we said, I told you that anytime you see something like this, whether they've added the first, second, third, and then the 10th, these people in, what you are going to do is you are going to subtract 1. So your x from here, since this one is, they've added this one to it, our x, so D, our x will be equal to 101 minus 1, which is going to give us 100. But if this one they said s is equal to 101, then that will be our x straight away. So that is the thing that you need to also have in mind. So what are we going to do here? Now r prime, since we are using r prime to estimate, now our x is 100, which will be equal to 1 over 4, 300 minus 2 times 100. So 1 over 4, then this is going to be 300 minus 200. This is 1 over 4 times 100. Can 4 divide 100? I'm not quite sure, but let's see. This is 50 divided by 2, and this is like 25. Okay, so 4 can divide this one, 25. So this will be the estimated change in revenue. Right. Then the last one is find the marginal profit function. So marginal means that we need to differentiate the profit function. So this is the profit function. Let's go and differentiate it, and then we are done. So let me write the profit function here nicely. Profit function was 280 280x minus x squared, yeah, x squared minus 160 divided by, I think, 4. Good. So as I said, we can write this one as 1 over 4 out, and this one will be left with 280 x minus x squared minus 160. So what will be p prime? P prime of x will be equal to 1 over 4 out. Use the power rule. When I differentiate 280x, I'm getting 280. When I differentiate x squared, I'm getting 2x. When I differentiate a constant, I get 0. So this is what I'm going to get at the end of the day. If I don't want to do any cancellation, and then this will be the final resource for finding the marginal profit. Right, so this is the question 5 that we just went through. Let's look at question 6. Question 6, we have this function. Question 7 too, we have this function, and we want to find the critical values of x, right? So when we started local Extrema, I told you anytime you want to find the local maximum or minimum, you need to find the critical values first, which are the x values, right? So what do we need to do? For critical values, we just need to differentiate this function and look for the values that will make f prime 0. So let's see what we are going to do. So what is f prime of x? Let's use the power rule. So we are going to have 3x squared minus 4x plus 1. I did it straight. So 2 multiply this one, give 1 4, subtract 1, you get this. When I differentiate this, I get 1. When I differentiate this, I get 0. So now let's do factorization so that we can know what we can do. Now when I multiply this by this, I'll have 3. So what are the factors of 3? 1 and 2, or minus 1 and minus 2. Right. So what can we do? Oh, sorry, this is supposed to be 3. So it means that since this one is minus 4, then we can pick this, right? So that when I multiply minus 1 to minus 3, I'll get 3, because we need to multiply this one by this. And then when I add this and this, I'll get 4. So I'm going to have 3x squared minus 3x minus x plus 1. So 3x will give us this, and then this time this will give us this. So now I have factored 3x out. What will be left? So I just want to group this. It will be left with x minus 1 on this side, right? And then here too, what I can do is, since I want to get x minus 1 here, and this is minus x plus 1, I'll factor minus 1 out. So minus 1 out, here will be left with x minus 1, right? Good. Then since this and this are the same, we can combine this and this. So we are going to have x minus 1, then 3x minus 1. So we can see that now when x is 1, this one will go to 0. And when x is 1 over 3, this one will go to 0. So for critical values, after you've done the differentiation and you've done your factorization, for critical values, f prime of x should be equal to 0, right? So it means that this is the f prime of x, which is equal to this. So it implies that x minus 1, 3x minus 1 should be equal to 0. So x minus 1 is equal to 0. This implies that x is equal to 1. Then 3x minus 1 is also equal to 0. 3x is equal to 1. And x is equal to 1 over 3. So the critical values are x is equal to 1 and 1 over 3. So that will be the critical values for the 6. So when they ask you to find the critical values, just differentiate the function and look for the values of x that will make the derivative to be equal to 0. Let's pick the 7. So 7, we have gen of x, which is equal to e to the power x, open bracket, x squared minus x minus 5. So for us to get the critical values too, so we need to differentiate gen. But how do we differentiate this? This is one function here, another function here. So we need to use the product rule, right? So if I want to do the product rule and bring it, this is my a, the whole of the one in the bracket here is my b. So what am I going to get? A is equal to e to the power x, b is equal to x squared minus x minus 5. What is a prime? We know that when we differentiate e to the power x, we've done it here, we are going to get e to the power x. Then when I differentiate b prime, what am I going to get? So power rule, I'm going to have 2x minus 1. So for the product rule, 1 a multiply a prime, sorry, b prime, and b multiply what? A prime. Or you can just do this because it's commutative, right? So it means that we are going to have, if this one multiplies this, we are going to have 2x minus 1 times e to the power x plus, then if this multiplies this, we are going to have x squared minus x minus 5 e to the power x. So this is what we are going to get. So here now, we need to figure out how we can group this in a way that we can see the values that's going to make the function 0, right? So the first thing I'm going to do is, I have ex, I'll factor it out. So ex out, what will be left when I factor this one out from here? To be left with 2x minus 1 plus When I factor this one out, what will be left? It will be left with this. But since this one is positive, I'm not going to bring the parentheses again. So I'll just write x squared minus x minus 5. Then let's try and do something here. So I have x squared, I have 2x, I have x here. So this is going to give us plus x. I have minus 1 minus 5, which is going to give us minus 6. So now we need to now do the factorization. Don't worry about this guy here, right? Because this guy is an exponential function, and we can say that this shouldn't be equal to 0 because we don't have exact value, like a specific value that will make this one to be equal to 0 unless x is equal to negative infinity. Before that one will get to 0. So we are not worried about this. We are worried about this, how to do the factorization and look for the x value that will make the function 0. So this will be, so x squared, factors of 6 are um 1, 2, 3, and 6. So we can pick 2 and 3. So I can, since this one is positive, I will make 3 positive and make 2 negative, so that 3 minus 2 will be 1. And then when I multiply 2, I get minus 6. So e to the power x. Now this is going to be, when I factor x out, I'll have x plus 3, right? So when I factor x out from here, that's what I'm going to get. Then here, when I factor minus 2 out, I'm going to have minus 2x plus 3. So this is the same as e to the power x. Then since this and this are the same, I can combine this and this. So I'm going to have x plus 3, x minus 2. So with this, we can see that now when x is minus 3, the function will go to 0, and when x is 2, the function 2 will get to 0. So now what are we going to say? We are going to say that for critical values, for critical values, f prime of x, sorry, g prime of x should be equal to 0, right? So what are we going to do? We are going to just pick this one. We are not mining this guy. We are going to pick this one and set it to 0. So x plus 3, x minus 2 is equal to 0. So x plus 3 is equal to 0 implies that s is equal to minus 3, right? Then we pick x minus 2 is equal to 0, and x should be equal to 2 from here. So the critical values for question 7 is 2 and negative what? 3. That's what you are going to get for the question 7. So let's do the last question on this exam review sheet. So the last question here is question 8. Now, if for some product the profit for making 90 units, that is P of 90 is equal to 146, and the marginal profit at X is equal to 90, which is this equal to. So what do you say? Remember, when we were doing the marginal profit is when we differentiate. So you see that it is here. And then we want to use the information to estimate this. So what is the formula for finding this? This is P of 97 should be equal to P of 90 plus P prime of 90, then 97 minus 90. How did I do that? This one is like equation of the line, right? So this one is like f of x minus f of x1, right, is equal to the slope. So the slope is f prime of x, and then x, right, x minus x1, right? So here our x is 97, right? So when I plug in the 97, I'm going to have f. So I'm going to have 97 minus f of x1, which is equal to f prime of no, our x. Okay, so this one should go with the x1 here. Good. Yeah. So f prime should go with x1. So this one will be x1, and then 97 minus x1. What is x1 here? X1 here is 90. So when I plug in 90, I'm going to have f of 97 minus f of 90 minus f prime equal to f prime of 90, then 97 minus 90. So that's what we are just doing here. So this one is just p. So if this one is p, you will see that this one will be p prime 90, 97 minus 90, right? Then when I move this one to this side and it become p, we have this one here. And to be left with this one when it is p, right? So all information is given. P90 is 146 plus p prime is 3. Then 97 minus 90 will give us 7. So 146 plus 21. And then when I add, I'm going to have 167. Right. So this is the end of the discussion sheet. I said discussion sheet, the exam review. So I'll drop the next video. I'll drop the discussion sheet that we are going to do tomorrow. And then on Wednesday, I'll drop one of the past exam on exam 2. I'll do full video on that, and then I'll drop it on Wednesday so that it can prepare you for your exams. All right, so see you in the next video.